Hi, this is Mr. Manley. In this video, I'm going to solve an equation with a variable exponent that is in quadratic form, in this three-term form. And if you recall, a quadratic, that would be an equation like this. And we would solve this by factoring or using the quadratic formula. I'm going to show how to use the method that we use for a quadratic with this that, like I say, it's in quadratic form. It's not exactly a quadratic. It wouldn't graph as a parabola, this expression, but it is in quadratic form. So I can set up this sort of factoring, this sort of binomial factoring that will allow me to solve this. So I can go 10 to the x and 10 to the x. Just stop and look at that for a moment, that if I do 10 to the x times 10 to the x, that is 10 to the x plus x, because we have a common base, and we have a common base, we add the exponents. And 10 to the x plus x is 10 to the 2x. So when I do my FOIL here, this first one, 10 to the x times 10 to the x, is in fact 10 to the 2x. With that said, now we're going to look at the last term, right? When we're doing this sort of factoring, we look at the 6. And I know that I need to use some combination of terms or some combination of the second term of each of these that has a product of 6. And you might be able to look ahead and see what's going to work here. That if I'm going to go minus 6 and minus 1, that will give me plus 6, which is what I need here. And when I look at the outside and inside of the FOIL, I'm going to have minus 1 10x minus 6 10x, which is minus 7. From here, we're going to use the zero product property, which says that if either of these factors is equal to 0, then the entire expression would be equal to 0. And now we're in more familiar territory, because if you're looking at this video, you've probably been solving variable exponents and using the definition of a logarithm. From this position now, I've got an expression in the form a to the c equals b, so I can rewrite that as log base a of b is equal to c. So I'll do that for this now and say log base 10, I don't have to write the 10, it's understood, of 6 is equal to x. And I have solved for x. For the other expression, or the other equation over here, 10 to the x equals 1, and I'll convert that to log form. Log base 10 of 1 is equal to x. Maybe you know that the log to any base of 1, if I'm ever taking the log of 1, regardless of what my base is, this of course is base 10, it's going to be equal to 0. So I actually have 0 is equal to x. So my solution here is x equals 0 and x equals log 6. Let's take a look at another one with a base e for the exponential expression. In this case, I'm going to say e to the x times e to the x for my first term of each of my binomials. 2e to the x times e to the x is in fact 2e to the 2x. Now we'll take this 3 here, and we've got to work that into these second term of each of these binomials, right? And that will be a minus 3 and a plus 1. Let's just check our FOIL here. We've already determined that that's e to the 2x. On the outside, I've got minus 6 plus 1, which is minus 5. Oh, I wrote this initial expression incorrectly. This should be written as, so right here, I should have written that as e to the x. Hope you weren't confused by what I was solving or how I was going about solving this. This is e to the x. All right, so again, I've got minus 6e to the x plus 1e to the x is minus 5e to the x. And then finally, I've got plus 1 minus 3, and plus 1 times negative 3, which is minus 3. And again, we'll go to the zero product property. 2e to the x plus 1 is equal to 0, or e to the x minus 3 is equal to 0. Isolating the e to the x, I get e to the x is equal to negative 1/2. Maybe you recognize right there that this is not going to yield a solution, but let's go ahead and continue and say that I'm going to convert this to log form. Log base e of negative 1/2 is equal to x. Of course, log base e is going to be written as ln, and that'll be ln negative 1/2 is equal to x. But hopefully we know by now, if you've been studying these long enough, that we can't do the log, we can't find the log of a negative value in this case. So ln negative 1/2 of x is not a solution that we're going to use here. For the other equation, we'll say e to the x is equal to 3. Log base e of 3 is equal to x. And of course, the log base e gets written as ln. And that is our one solution. And there we have cases where we can solve for a variable exponent if it is in quadratic form. Notice that for both of these, we were able to factor the quadratic expression. That wouldn't necessarily be the case. And if we didn't, there would be a way to solve that by using the quadratic equation. But that is for another video. And this video we're just looking at these quadratic formed expressions that can be factored and solved in this way.